Up.
I'm going to do it instantly.
So example 9.5, which is on page 290, says, consider the reaction of powdered aluminum metal and finely ground iodine, okay, to produce aluminum iodide. So we have aluminum plus iodine, which is what?
I2.
I2. Does that say it? Oh, that should be iodine. Oh, it does say that. Okay, good. Iodine to produce aluminum iodide. Who can tell me what the formula for aluminum iodide is?
ALI3.
ALI3, thank you.
Yeah.
ALI3. Okay. And this is a solid. And this is a gas.
So do solid gas actually become important here?
I didn't understand you, Zach.
Sorry, I was yawning. Do solid and like gas and stuff actually become important when we're doing stoichiometry?
Well, sometimes it does, but usually it's just kind of helpful for you to understand what's going on. Okay, so then the first thing we're going to do is balance this equation. Who can balance the equation for me?
Yep, 2, 3, 2.
Okay, thank you, Isaac. 2, 3, 2. Okay, so we have 2 moles of aluminum plus 3 moles of iodine yields 2 moles of aluminum iodide. Good. All right. And it says calculate the mass of iodine needed to react with just 35.0 grams of aluminum. Now I like to do I like to put the amounts under the thing just because it helps me to visually keep track of what's going on. So I have 35.0 grams of aluminum, so I'm going to write that right under aluminum, and I'm going to write my question mark under the thing that it's asking me for, which is what?
How much iodine?
And what am I looking for iodine?
Grams.
Grams. So I'm going to write question mark grams right there, okay? Alright, so the first thing that we need to know is that when we're doing stoichiometry, you have to remember that you cannot convert directly from grams to grams. What do you have to go through? Moles, okay? So in order to do grams of iodine, which is what I'm looking for, I'm going to put question mark grams of I2 equals, and then I'm always going to write down, okay. Alright, so, and then I'm going to put down what we're starting with, which is what?
35.0 GAL.
Grams of aluminum, right. Now, I have to convert to moles first. And what is it that we use to convert to moles?
Molar mass.
The molar mass. What is the molar mass of aluminum?
A number.
27. 26.98. Good.
Wait, didn't we already do some of these in the chapter 10 assessment? Okay.
Well, in the chapter 6, we did them in. You might have done some.
Wait,
Why
When you
can't we
assigned
round
the chapter
27?
assessment 1 through 10, we did some of these.
Why can't? Let's do round 27.
Isn't it?
Okay, shh, listen. Alright, first of all, yes, you may have done some of these before, and second, Zach, you never want to round until you're at the end, otherwise you're going to get wrong problems, because when you start multiplying, rounding things, then your answer gets further and further away from the actual answer. Isaac?
Doesn't that go on the bottom?
That's my question, too.
Yes, it does.
Right.
Good point there. Okay. Thank you, Isaac. Okay, so let's try this again. Okay, so the 26.98 grams is going to go on the bottom. And Tabby, I'll get to your answer, your question in just a second. And 1 mole of aluminum is going to go on the top. Okay? And the reason that we're not going to put the 2 here is because this is this is the molar mass, and the molar mass always has 1 mole of aluminum. You're basically saying that this is how much 1 mole weighs. If I had 6.022 times 10 to the 23rd atoms of aluminum, this is how much it would weigh. Okay? So when you're doing the molar mass, it's always 1 mole. Always, always, always 1 mole. Okay? But there is 2 moles in the equation, and we have to account for that. So that's what we're going to do here next. So now we have 1 mole of aluminum, but we want to go to iodine. Okay? And so we need to convert from aluminum to iodine. And what do we use to convert that? What is going to tell us how much iodine, the ratio between iodine and aluminum?
The equation.
Right, the balanced chemical equation. Which is going on the bottom, aluminum or iodine?
Iodine.
Wait, no, aluminum is going to go on the bottom. So how many moles of aluminum do we have? 2. So we're going to have 2 moles of aluminum right here. Okay? And what is going to go on the top is the moles of iodine. And how many moles of iodine do we have? 3. Okay. I'm going to run out of room, so I'm going to have to go down here. Now, how do we know that the moles of aluminum are going to go on the bottom?
Because it'll cancel out.
Right, because we want to cancel because we want to get rid of that. And now we have moles of aluminum up here. So since we have moles of aluminum on the top over here, the moles of aluminum have to be on the bottom here. Okay? And so now we have moles of iodine on the top, but are we looking for moles of iodine?
No.
No, what are we looking for? Grams. So we're going to have to go, and this is just continuing on, but I'm running out of room, so, this is the same equation. So we want to convert, okay, so what am I going to put on the bottom here?
Moles of iodine.
Right, how many moles?
3.
No. 1. Why is it 1? Yeah, because that was the last answer you had. Okay, what are we using to convert back to grams?
The atomic weight.
The molar mass. And what did I just tell you? The molar mass, there's always, always, always how many moles? 1. When you're doing the molar mass, it's always, 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 always 1 mole. Okay? So what is the mass of iodine?
Wouldn't it be 126.90 times 2?
That would be correct, Zach. Good job.
So,
Couldn't you just find the number of moles?
and can we split it up? This whole stringing all these equations together.
Yeah, it's easier
That's
maybe
what I
if we
was
split it up
asking.
too.
Yeah.
Okay. It may be easier for you if you split it up, and you can do it that way, but I'm going to tell you 2 good reasons why not to, and I will not split it up. If you want to do it that way on your own, you can, but here are my 2 good reasons why it's better to do it this way. Number 1, you have less rounding errors because every time you split it up, you're going to truncate the significant digits, and so you're going to have a multiplied rounding error, so you're going to have a less accurate answer. And number 2, you don't have as many of the automatic self-checks built in so that you can see that everything cancels. Okay? Now there's sometimes it's going to be, you're going to have to split it up, but my advice is always if you can do it without splitting it up, it will be better for you in the long run. Okay? So, and it's not wrong to split it up, but it is better to not. Okay? So, we have 253.8 is the grams of iodine, and again, like Zach said, we got that by multiplying 120. I can't see from here.
126.9.
126.9 times 2 because it's I2. Okay? Alright, now we're going to go back and cancel before we calculate to make sure that we have everything the way it should be. So we're starting with grams of aluminum, and that's on the top, so we're looking at grams of aluminum on the bottom. That cancels. Now we have moles of aluminum on the top, and we see moles of aluminum on the bottom over here, and it cancels. moles of iodine is on the top over here, and here's moles of iodine on the bottom here, and that cancels. And in the end, we should get the thing that we're looking for. So here's grams of iodine is all that's left, and grams of iodine is what we were looking for, and that tells us that we probably did the problem right, okay? So now we're going to put this into our calculator, and you're going to put in 35.0, and when am I going to put times or divided here? Divided by 26.98, and then
Times 1.5.
yeah, times 3 divided by 2, or times 1.5 if you can do that in your head. And then times 253.8. Okay? And we get an answer. We get our answer, which is 493.8. Right, 493.8, and how many significant figures should we have?
70.9.
2.
It would be, but we're going to round more than that. No, 2 is not the correct answer.
3.
3, because we have 3 significant figures here, 1, 2, 3. So we're going to have 494.
Yeah.
Failing 0.
Failing 0 in this decimal.
Struggle.
494 grams of iodine. Make sure that you don't forget your units, or you'll end up losing points on your test. Okay? Now, does anybody have any questions about this example problem? Emily?
Like, I mean, I understand what's going on in his videos and stuff, and I understand what we did, but like if I were to do it by myself, I would just feel like I'm pulling numbers from random, and I just don't know where they're coming from.
Well, some things you're, okay, there's some things that you learn by memory, and then there's some things that you learn understanding, and some things you have to do both with. And so one of these things, this is a new skill, and it's going to feel like you're just pulling things out of the air to begin with, but after a while, after you practice it, it'll start to make sense, okay? But this is what, if we review this, these are the steps that you're going to do, okay? You're going to start by writing down question mark what you're looking for, okay? Everybody got that? Okay. Then you're going to write the equal sign down. Everybody can handle that, right? Then you write down what you're given in the problem.
We'll always be given something, correct? Otherwise
Yes.
you can't do anything?
You can't do anything if you're not given anything. So whatever you're given in the problem, okay? Now, if it's grams, you know you're going to need to convert to what? Moles. So you're going to use the molar mass, and it's going to be put into the problem in a way that cancels this out, because that's what you want to do. Once you put it in there in a way that cancels out what you need to cancel out, you're looking at the top here, you have moles up here. You're going to be using this conversion from the periodic table. That's not a periodic table, that's a chemical equation. So you're going to be using this mole-to-mole ratio from the balanced chemical equation. Okay? You're still canceling what you need to cancel. And then if you're looking for grams, you're going to have to convert back to grams. Now, if they ask you to just determine the moles, then which step are you going to leave off?
The last one.
The last one. Or if they give you moles to begin with, which step are you going to leave off?
The middle, or the first one.
The first one, right. We would just leave off this part here if we were given moles, okay? And that is something that I've had chemistry students do sometimes in the past. They get so used to doing the whole thing that sometimes they don't think about the fact that the problem only asked them to go to here, and they just do the rest of the problem, even though it didn't ask them to. So make sure that you do pay attention to those self-checks that are built in. In the end, you should have the units that you're looking for, okay? So make sure that you do, okay? And pretty much this, if you follow this routine, it's gonna, you're gonna cancel and cancel and cancel until you get what you're looking for, okay? And you're gonna work it through, it's fine. All right, let's go on to the next one. It says, example 9.6, solid lithium hydroxide. What would be the formula for lithium hydroxide?
LiOH.
LiOH. has been used in space vehicles to remove, well, that's an interesting word.
Exhaled.
Okay. Exhaled carbon dioxide. I guess we will continue this later. But your assignment is to do section review, notes, and 9.2, and I did put it on red. So
What's the notes?
no, the problems too.
Okay. Wait. Notes and questions, Isaac.
Can I take my test?
And can I turn into my
Didn't have hurry today. You got your
there, so I was just boxing it.
Oh, I know it's supposed to work.